measures of central tendency. Okay, the measures of central tendency is used to describe a data set in a single value, which can be mean, median, or mode. Right? Okay. As we said, measures of central tendency is used to describe a data set. Right? Sometimes the measures of central tendency do not necessarily provide enough information to describe a data set adequately. That is, for example, consider two samples. Okay, sample 1, 230, 250, 245, 258, 265, 240. And here we have our sample 2, 190, 228, 305, 240, 265. Consider two samples given. Okay, let's calculate the mean of two samples. What is the mean of these two samples? Mean of both the samples equal to 248. Okay, see, both this, the central tendency of or the mean of both the samples are same. The mean of both the samples are giving the same value, right? But still, look at the samples. The samples are variable, right? What about the first sample? When we compare the first sample with the mean, we can see that all these values are closer to mean, right? More or less closer to mean, right? 230, 250, 45, 58. All these values are closer to the calculated mean. What about the sample 2? We have 190, 228, then 305, 240, 265, 260. The values are a little bit far away, right? That is, we can say that the scatter or the dispersion of first sample is less than the scatter or the dispersion of second sample, or else vice versa. The scatter or the dispersion of second sample is much higher than the scatter or dispersion of the first sample, right? Scatter or the dispersion. See, which means the second sample is more variable than first sample, right? Variability. Okay. Here we have the measures of dispersion. Measures of dispersion is used to study about variability of the items. Okay. See, when we calculate mean, this mean is not providing any information about the variability of the sample. Okay. Measures of dispersion help us to study the variability of the sample. That is, for example, let's say we own a company and our company manufacture glass bottles. Okay, and we have manufactured 100 glass bottles. The glass bottles have so many characteristics, right? The color of the glass bottle and shape of the bottles, then breaking strength of the bottles, etc. etc. Let's take one characteristic. Let's say the breaking strength or the breakability of the glass bottles. Okay, if we have listed the breakability of the glass bottles, for example, 223.98 psi, then 220.13 psi, then 215.85, etc. If we list it like this, okay, although all these glass bottles are manufactured in the same company using the same machine, there are chances of variability. Okay, one single characteristic and check with these 100 bottles, there are chances for variability. Okay, in order to study this variability, we use measures of dispersion. Okay, in statistical sense, dispersion has two meanings. Oh. Let's write those samples once again, okay? 245, 258, 265, 240. This is sample 1. And sample 2 is 190, 228, 305, 240, 265, 260, and the mean is 248. Right? Okay. So, what was we were saying about? Yeah. In statistical sense, dispersion has two meanings. The first one is that how each value, okay, is diverse among themselves. Okay, how these items are diverse among themselves, variable among themselves, which means, see, between 230 and 250, there is a difference of 20. Between 250 and 245, there is a difference of 5. Between 245 and 256, 58, like that. Okay, the variability among the items. Okay, the second meaning is that how each item is variable from the mean value. We'll calculate the average first, then we'll check how each item is variable from the mean. 190 minus 248. Okay, 228 minus 248, 305 minus 248, like that. Okay, so in statistical sense, dispersion has two meanings. First one is that variation of items among themselves. Okay, what is the second one? Variation of the item around the average. Okay, these are the two meanings for dispersion in statistical sense. Okay, I hope you understood. Then, next thing is that, let's see. And one important thing is that, likewise, we calculated measures of central tendency to describe dispersion of items in a data set. We have some descriptive statistics which are variance, standard deviation, and range. Okay, so the dispersion of the items in a data set can be described using either variance, either standard deviation or range. Okay, whichever may be calculating, one important thing is that the measure of dispersion will always give a non-negative real value. Okay, I mean whatever may be, we may be calculating variance, standard deviation or range. In measure of dispersion will always give a non-negative real number. Okay, and then yeah, one thing. Okay, let me ask you this. I calculated. Let's say, okay, I calculated the length of Apsara pencils. I have taken 5 Apsara pencils and I calculated the length. Okay, let's say 20. This is the length of, in centimeters, okay? This is the length of 5 Apsara pencils. My question is, what is the dispersion of this data set? Yes, since all these items are exactly the same, the value of dispersion is 0. Okay, if there is some variability, the value of dispersion will increase, okay, with increase in variability of the items. Okay, so we said that dispersion have 2 meanings in statistical sense. First one is that how they diverge among themselves. So if the values, the diversion, how diverse the values are. Okay, with increase in dispersion or scattering, the value of dispersion will get increased. Okay, or we can say that from given a data items and average value is calculated. If the difference between an item and the average is high, then we can say that the value of dispersion is also high. Dispersion is high, not value of the dispersion is high. Okay, and if the difference between an item and the average is less, then we can say that the dispersion is relatively small or less. Okay, so the dispersion of data items can be described using variance, standard deviation and range. Okay, we'll see these one by one with some examples. Okay.